If we consider a 20 kilogram mass at rest on a surface, it is being acted upon by the gravitational force, found by m times g, and that is 200 newtons downwards. As gravity pulls the body downwards, it pushes on the surface, and according to Newton's third law, the surface reacts and acts a normal force in the upward direction on the body. If the body was stationary, the normal reaction force and the gravitational force will be equal. Now let's consider applying a force to the body in order to slide it to the right. Let us say that we applied a force of 150 newtons on the body at an angle of 30 degrees above the horizontal. This would have a horizontal component which will cause the body to accelerate towards the right, and thereby let's assume that there will be a friction force acting on the body, and that will act to pull the body to the left. And let's say that for the particular surfaces the friction force was 60 newtons. Now, would the normal reaction continue to equal the weight? No. Let us explain why. If you have the 150 Newton force acting at an angle to the horizontal, that means that this force has both an upward component and a horizontal component. Analyzing this situation, we get the situation on the right. So let's see what has changed. We have taken the 150 Newton force acting at an angle to the horizontal and have resolved it into two components. So 150 newtons acting at 30 degrees to the horizontal is equivalent to a vertical force of 75 newtons and the horizontal component force of 130 newtons. Since the body was only sliding along the horizontal, it means that the vertical parts of the forces must sum to zero because there is no acceleration along the vertical. So the F normal force in this case equals to the F gravitational. However, now that the applied force is there, it has an upward component of 75 newtons and the gravitational force is 200 newtons. The sum of the vertical components must still be zero. So if we sum up the normal and the y component of 75 newtons, we must get in total the downward forces, which are 200 newtons. So downward forces must equal the sum or the total of the upward forces. That makes the normal reaction force equal to 125 newtons. While the vertical forces are balanced, the normal force being 125 plus the upward component of the 150 Newton force being 75, that makes 200 newtons. Gravitational force is also 200 newtons. The horizontal components are unbalanced. That means that there is a net force acting towards the right. Since the x component is 130 newtons, that's bigger than 60 newtons. So since there is a net force to the right on the 20 kilogram mass, Newton's second law states there will be an acceleration to the right. Furthermore, we can find the size of this acceleration. So if we apply Newton's second law to this mass, looking at the net force is 130 minus 60, and the mass is 20 kilograms. Applying Newton's second law leads us to an acceleration of 3.5 meters per second squared. The acceleration will obviously be in the direction of the net force. That's towards the right. If you want to be reminded about how to resolve the vector at an angle to the horizontal, please visit one of our other videos. In this case, the resolved component of the 150 Newton force along the horizontal is 150 times the cos of the angle 30. So 150 times the cos of 30 gives us 130 newtons, almost. And the vertical component is found by the sine, multiplying 150 with the sine of the angle 30 to find this side, which is therefore equal to the vertical component.